Hi everyone, it's Linnea Tucker. This is CPM3, Module 3, Lesson 6. We are going to graph quadratic functions. This is section 18.6 in your textbook. Okay, we know what a quadratic equation is. We've worked with those. And a quadratic equation in standard form is ax squared plus bx plus c. Now, I have graphed 4 different equations, so we can compare and contrast how these graphs are the same and how they're different, and what kinds of things can we glean from our equations that are given to us. Okay, the first thing I notice is these 2 graphs on the left-hand side, they open upward. And I want you to notice the ax term, or ax squared, in both of these equations. All right, these 2 graphs over here open downward. And I want you to look at the ax squared term in both of these equations. What is it about the equation that's forcing these 2 on the right-hand side to open downward compared to these 2? Yeah, it's this negative a, or the negative ax squared term. When you have a negative in the front of your ax squared term, it forces it to open downward. Okay, a vertex. Vertex is the point on the graph. Oh, and by the way, these graphs, the name for these graphs are called parabolas. If you graph a quadratic equation, the equation forms a parabola when it is graphed. And the parabola either opens upwards or it opens downwards. It only opens upwards or it only opens downwards. It never opens sideways. The point at which, as my x values are increasing, here my y values decrease, 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 and then at this point they turn around and my y values start to increase again. This inflection point is called the vertex. We have a vertex here and a vertex here. If you look at these 2 graphs, the vertex is a minimum. That is, your y values on the graph are at a minimum at the vertex. This is the lowest y value in each one of these graphs. As opposed to these over here, your vertex is here, as my x's are increasing, my y is increasing, 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 inflection point decreasing, decreasing, decreasing. Your vertex here and your vertex here on the right-hand side are not minimum values, but they're maximum values. This is the largest y value in your graph. What about y-intercepts? Let's take a look at the y-intercepts. Okay, I got a y-intercept right here at 4. Take a look at that. That's my c. Down here, I have a y value or an x-intercept at 3. Look at my equation here. Look at my c. It's also a 3. Okay, over here, my x-intercept, even though that dot's in the wrong place, it should be right here at 5. My y-intercept is positive 5. Look at my c term in my equation. Down here, this y-intercept's at negative 3. And look at that guy. My c in my quadratic is a negative 3. So your y-intercept is always the c term in your equation. It's the constant in your equation. Okay, so this is number 1. If you've downloaded the lecture guide, this should be example number 1. What we're going to do is give you the equation only and have you graph it. But in these first couple of examples, I'm going to give you both. I'm going to give you the equation and I'm going to go ahead and give you the graph that goes with it so we can kind of see things as we're going through this. but our whole goal here is to graph it. Well, the first thing I notice about the equation is my a on the ax squared term is positive, and I know it should open upward. The next thing I notice about the equation is my c term, or my constant, that's positive 4. So I know I have a y-intercept at 4, and I can go ahead and graph that. Now, yeah, there you go. Looking at the graph, since they gave it to us, I know my vertex is right here at -2, 0. I want to show you mathematically how you can come up with the vertex so that you can graph it yourself. See the x-coordinate of the vertex, the -2? There's this little tiny formula that will help you find the x-coordinate of your vertex. It says x equals, and I just say the opposite of b over 2a. Well, if we look at our equation, my a is 1 and my b is 4. I'm going to list those out just like I did with the quadratic equation. If I substitute those into the little equation here, I get -4 divided by 2, which is -2, which is what we saw visually, so it matches. How do we calculate our y value? Well, look at this. I have an equation that essentially says y equals x squared plus 4x plus 4. I'm going to plug in my x-coordinate of -2 into the equation and solve for y. And when I do that, I get y equals 0, which is what we have right here. So I can calculate the vertex and I can graph it. The axis of symmetry is a vertical line that passes through the vertex. And the cool thing about your axis of symmetry is every point on one half, let's say the right half, every point on the right half of your graph reflects across the axis of symmetry to create a point on the left half. All right, for instance, the one point that I have right now is the y-intercept. I can reflect that across the axis of symmetry. Let's see, if you look at the scale here, each one of these grid lines is 1/2. So here's 1. From here I can go over 1, 2 to the axis of symmetry, so I'm going to do the same thing. 1, 2, and there should be a point right there. If this point is 2 to the right of the axis of symmetry, this point is 2 to the left. Okay? You need 5 points to define your parabola, and we only have 3. I need 2 more points. I could find the x-intercepts. What's always true of an x-intercept? My y is 0. So if I plug 0 in for y in the equation, f of x is the same as y, so replace that with 0. I went ahead and factored this quadratic. It was easy to factor. I got it, quantity x plus 2 times the quantity x plus 2 equals 0. I'm going to use the 0 factor property and set each factor equal to 0 and solve for x. I get x equals -2. Well, I already have a point at x equals -2. That's the vertex. So that didn't help us get an additional point. I need one more point that I can then reflect across the axis of symmetry to have 5 points. So I'm just going to pick a number like, I don't know, let's pick an x of -1. If I pick an x of -1, I'm going to plug it into my equation, and I'm going to use orders of operation to do the math, and I get y equals 1. So I have another point, -1, +1. The 5th point is a reflection of this point across the axis of symmetry. If this point is 1 unit to the left of the axis of symmetry, I've got to have another point 1 unit to the right of the axis of symmetry. So now I have the 5 points I need to define the shape of my parabola. This is, if I'm graphing on my own, this is where I'm going to try to draw this curvy shape and put arrowheads at the end of the curve. But just remember, this curve never goes vertical. It's always going to get wider and wider and wider. Okay?